Hi, this is RaziehZaeem, and we've got a short teaching lesson for us today.
Okay, so hello. I'm gonna pretend I'm teaching this class today. I will cover the Singleton Pattern, which is a design pattern, and we'll look at slides and code, and we'll go from here. So what is Singleton Pattern? Singleton Pattern is a design pattern which, like any other pattern, it gives you a high-level solution to solve a problem to see when you're writing a software. And what Singleton Pattern does, it ensures that a class has exactly one instance. And it also provides a global point of access to that instance. The name Singleton comes from the mathematical concept of a singleton set, which is like a set that has exactly one instance. If you know some programming, for example, if you have programmed in Java, you know that this idea of having exactly one of something is very similar to a static, but it's not exactly the same, because even though you can implement singleton with a static, you don't have to. There are other ways of doing it, and then it has some differences with the static. For example, you can do lazy initialization, which is something you can't do with the static variables. And Singleton Pattern is there for you to use, and then it gives you flexibility. So in case you change your mind that I designed this class with Singleton Pattern, and in future I figured out that I don't need exactly one instance, maybe I need more than one instance, you just change the pattern, and then you don't have to change anything about the client code that uses that pattern. Today we will cover 4 different implementations of writing the Singleton Pattern in a class. The first one is eager implementation. Eager is as opposed to lazy. It uses a static, so the concept is similar to a static, and once you're eager, you can essentially use the static keyword inside, and we'll see examples of that. Because it's eager, once you use the class, once you load the class, you have exactly one instance, and there is no way to do it lazily in this implementation. The implementation is thread safe by itself, so you don't have to synchronize anything when you want to do multi-threading, and you make the constructor private, and you use final, and I will show you how to do this in this code. So here is an example of a singleton class that uses the eager template. We have one instance over there that's called instance, and we made it private so that nobody outside the class can reach it. We made it static so that there is exactly one instance. We make it final so that we do not accidentally overwrite it in this class. Well, others don't have access, so they can't do anything about it. And then we initiate it over there. This means once the class is loaded, there is an instance, because the initialization is called. And this is the get instance method. It returns that one instance that exists. We are going to have to define a private constructor for it, because if we don't do this, if we miss this line, there's going to be a default constructor, and the default constructor is not private. And we don't want that. We don't want anybody to create more than one instance of this guy. So we have to, how many constructors we have, it doesn't matter, but we have to make all of them private. And if the code functionality doesn't require us to have a constructor, we have to put at least this one line in here. So this is an example of eager singleton. I'm going to show you how we can use it and what it means to use it. So let's say we have 2 different instances of that class, and we, as the template suggests, we get both of them through get instance. I'm going to compare the object identity of S1 and S2, which both come from get instance, and we will see that it returns true. Meaning that the object identity of this object and this object is exactly the same thing. Okay, next way of implementing Singleton. This is called the lazy implementation, and like the previous one, it uses a private constructor, but because it's lazy, no instance is created before you call get instance. We use this model when it's very expensive to have an instance if we don't need it. Maybe it's computationally expensive, maybe it takes a lot of memory, maybe it takes a lot of time. And then this method, this way of implementing Singleton, it's not thread safe by itself, so we have to synchronize the get instance method. So let's take a look at my lazy Singleton. The instance that I have over there is private. Nobody outside this class can access it. It's static, meaning that there's only one instance of it, but we do not initialize it over there, and we do not make it final. We don't make it final because we need to initialize it in here in the get instance method. The private constructor has to be there. In the get instance method, we first check if we already created the instance. If we already created it, it's not null. So we return the instance that we do have. If we did not, so it's null now, then we go ahead, call the constructor, create one instance, and then return that instance. Without this synchronized keyword, this way of implementing Singleton is not thread safe. Because, well, in a real class setting, I will ask somebody why it's not thread safe, but anyway, because two different methods, two different threads might get here at the same time. They both check and see instance is null. At the same time, they both come in here, and we end up with two different instances of the instance, the Singleton instance that we only want.
Is it thread safe inside of new, or is new also unsafe?
Okay, so are you talking about this guy?
The keyword new. Is new thread safe? So if I said instance 1 equals new lazy Singleton, and I had somewhere else I said instance 2 equals new lazy Singleton, is the new itself thread safe?
Okay, if I understand your question correctly, we're not gonna call new to instantiate instances of this class. We're gonna have to call get instance because we made this private and nobody can call it. If you're talking about inside this class, or
no, I'm talking about the new itself.
General new.
In general, is new thread safe?
No, not necessarily. I don't think it is.
I can't imagine how it would be. But
Well, you can always make it thread safe. Right?
You can make
okay.
it.
I don't know what Java says, honestly.
But as
that's
far
what
as I know,
synchronize
there's
makes it thread safe?
in Java, that's the key.
so
Okay.
synchronize makes the whole
Synchronize is a
block
mutex
thread
on-
safe.
Gotcha.
But I don't imagine this guy by itself is thread safe. So if, for example, if you have a way of making this guy thread safe and this guy thread safe, but this guy not thread safe, I don't think it works.
Okay, very good.
I mean, a good designed language, it should. Anyway.
Okay.
Anyway, now we're getting into philosophical.
We won't stretch.
Okay. I'm not sure. So that's what I think. Okay. Then what happens? Okay. So I talked about all the points. Okay. And then there is this third way of implementing this Singleton pattern, and it's set to use the initialization on demand holder idiom. This is a name that we call it. It combines the passive points of both eager and lazy initialization. So by passive points, I mean it's thread safe by itself and it's lazy. So the good things from both lazy and eager implementations. So let's take a look at the example. Let's call this one. So the way we implement this is we have a holder class outside, and then we have another class inside, which is a private static class inside that class. This internal class keeps an instance of the external class and instantiate it, and that's the instance we have. What happens is, what makes this implementation lazy is when you load classes, you won't load this class. You will load this class, but you won't load this class unless you access anything from it. So that's what the class loader promises you. It won't instantiate an instance, and it makes it lazy unless you call that internal class somewhere. And the only way we are calling that guy is inside the getInstance method. So when we write the getInstance method, we return singleton holder, which is this guy, dot instance. This is a workaround, a beautiful workaround to make it make the implementation both lazy and thread safe without synchronized. It's thread safe obviously because this guy is a static.
Does this work in C++? Well, I mean, I don't know how.
The entire. Oh, okay. So it depends on how the class loader works in C++.
Yeah, I think it would, right? Class gets only
I
created.
suppose.
Yeah.
It depends on the class loader. But I'm sure it works in Java. I guess it works in C++ too. That's what I'm thinking. Okay, so this was the third way of implementing this guy, and then the fourth way is implementation using enum. This implementation works only in Java after Java 5. Before that, you can't write it this way. You won't have this way of using enum. And then it uses the property that enum values are obtained only once. That's what makes it singleton. And also, it uses the property that class loader initializes enum lazily. And this method has its own drawbacks, but its own pros and cons. One pro about it is reflection cannot break this. So reflection can break all the other previous methods, and I'm going to show examples of how it can do it. You can get your hands on the private constructor through reflection and then use it to break the singleton pattern. But this guy, you can't do it with reflection. You can't break it with reflection. But enum is not as flexible, I would say, as a typical class. So it has its own problems. For example, you can't subclass enum like you subclass a class. So let's take a look at enum singleton. So instead of a class, we have an enum here. And we have one instance in it, and we have the getInstance method, which returns the instance. It is a static, so there is only one instance, and there is no synchronize needed because it's static. And we are not checking if it's null or if it's not null. At the same time, it supports lazy initialization because of the property of enums. Now let's take a look at how reflection can break the first 3 implementations, but not the fourth one. So I have getInstance to get instance 1 of one of the singletons. Let's look at eager singleton. Oops. Oh, okay, I broke it. Okay. And then for the second instance, I use getDeclared constructors, which gives me the constructor, even though it's private. The getDeclared constructors works on it, and then I use that to create instance 2. And then if I use it with any of eager singleton, lazy singleton, or the holder singleton, and I run it, no. Oops. It returns false, which means by using the private constructor through reflection, I obtain 2 different instances of this singleton. But if I use the enum singleton here, and it's the same case for the other 2, but if I use enum singleton here, It says you cannot reflectively create enum objects because simply you can't. It's not a class. But this is not ideal because enum, well, enum is not as flexible as a class. But so like any other pattern, and maybe more than any other pattern, should be very careful when you use it because many have said that people just overuse this pattern and they end up creating a spaghetti code that hinders every good thing about object-oriented programming. You should use it very, very carefully. Only if it makes sense to have exactly one instance and not more under any circumstances. So we should use it very carefully and avoid introducing global state. We should have the object-oriented mindset and use this, not just creating everything and making everything singleton. Singletons, they are better than simple global variables because they allow lazy initialization, which global variables through a static do not, and then they keep the namespace clean so that you don't have a lot of different variable names here and there that clutter the namespace.
But you could do globals within namespaces also, right?
Yes, you could.
Okay.
So that's for languages that, so you don't have namespaces in Java,
Okay.
but you, for example, in C++ you do. And then singleton pattern is used in many different patterns. For example, in facade pattern, this facade pattern is a pattern in which you create as in a building that has a facade, you create one single interface to hide all the complexity that you have inside your code, and then provide one single interface that other people can interact with. It's used in other patterns, for example, in abstract pattern, factory pattern, which is like an abstract type of the factory pattern, and then in the state pattern. Yeah, so that's pretty much all I have on this. Any questions?
No.
No.
Thank you.
Yeah.
Thank you. I'm
Thank
going
you.
to shut
We
this
can
off.
pretend to be, no,
Got to-
that's fine. No, that's okay.
I tried.
Okay,
I
thanks.
tried to pretend to be.